So yesterday we took a look at the eyeball, what a normal eyeball looked like, and we also looked at some of the common eye defects that might cause somebody to have to wear glasses. So today we're going to put it into action and we're going to see how things actually change when the rays are going through your eyeball. So we're going to use what we call an LED light box and optical kit. So there's what it looks like. We've also got all the components to the kit. I've got a bunch of different paper setups here, and then a few different eyeglasses that I found around the house just to try this one out. Now we have to actually film this one in the bathroom today because I need to be able to get it nice and dark in here. So we're going to start off with the perfect eyeball that has nice 20/20 vision. So if you look, it's got a nice round sort of shape to it. I'm going to grab my LED light box. I'm going to turn it on. It's hard to see right now, but we've got some light coming out of it, and I'm just going to kill the lights in here. All right, so right now we've got, so this setup here is showing what would happen if we had no lens in our eyeball, and because the rays don't converge on the retina, we wouldn't be able to see anything. So I'm just going to take a convex lens and I'm going to pop it in there, and what it does is it gets the rays to converge, and if you look, you can see the retina is right here where my finger is. I know it's a little dark, but we should be able to see it, and we see that our rays converge directly on the retina, and because of that, the proud owner of this eyeball would be able to see perfectly clearly. They would have what we call 20/20 vision.
"20/20 vision. We all know it means perfect eyesight, but what exactly do the actual numbers mean? 20/20 means that you can see something 20 feet away from you that a normal person can also see 20 feet away from themselves. The numbers change as your vision gets better or worse. For example, you're considered legally blind when you have 2200 vision, meaning that you can see something 20 feet away that a normal person can see 200 feet away. Not so great. A person with 20/10 vision can see something 20 feet away that a normal person can only see at 10 feet, which means you're practically superhuman. Way to go. Thanks for watching, everyone. Please like and subscribe to this channel for more videos. And if you have an idea for a future video, let me know in the comment section below.
This next example here is an eyeball that we would call far-sighted, meaning this person can see things that are far but has trouble seeing things that are close up. So if we look, the retina is here, but in fact our light rays are converging way over here, which means that anything on the retina is going to appear to be a little bit fuzzy. So if we remember, we know that we need to use a convex lens. So I'm going to pop a convex lens in here in front of the eyeball and see what happens. All right, that one looks like it made a real nice bit of difference there. It looks like we're quite close to the retina, but I think maybe we can do a little bit better. Pardon the noise in the background. It's still spring break and Mr. Maskew's working hard in the basement here. So there we go. This is going to give us perfect 20/20 vision. We're going to be able to see everything perfectly because the rays meet right at the retina. So the only actual convex lens that I could find in the house was from Mr. Maskew's reading glasses. Now he's not real far along in terms of needing them. So if I pop them in front there, we're going to see that they actually have very, very little effect on the light rays. Okay, it makes very little difference, but enough that he's able to read the newspaper properly. So here in our third and final setup, we have that problem that lots of you people out there have, and that is that our eyeball is short-sighted or nearsighted, meaning we can see things that are near to us, we can read things really easily, but we have difficulty when things are further away. So the reason that this happens is because the rays are converging before they get to the retina, and by the time they get to the retina, they've already spread further apart, and so therefore things are going to be a little bit fuzzy. So we know that we can fix this using a concave lens. So let's give a concave lens a little bit of a chance. I got one here that doesn't have a whole lot of curve to it, so that made a pretty significant difference. It looks like it actually was pretty much what we were looking for. I'll pop something in here that had quite a bit more curve to it, and you see that now things are converging way down the road somewhere, and that's overcorrected. So I found 2 pairs of glasses at home meant for this problem. These are the ones I wear when I'm driving. And you see that there is almost no difference, which is why I don't wear them very often, because they don't make a whole lot of difference for me. And then there's the other glasses that I used to wear before I had laser eye surgery about 15 years ago. Let's see what those ones do. All right, so that overcorrects the problem drastically, right? Okay, I pop those in, and those are way too strong. And interestingly enough, sometime in the next little while, we're going to learn all about laser eye surgery.